Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Mobile ports and connectors are essential to the operation of smartphones, tablets, and laptops, enabling users to charge devices, transfer data, connect accessories, and establish wireless communication. These interfaces include both physical and wireless technologies, each designed for specific use cases and levels of performance. The A+ certification exam frequently tests knowledge of these interfaces, including how to identify connector types, understand their functions, and troubleshoot common connection issues across a wide range of mobile environments. Universal Serial Bus, or USB, is one of the most common physical interfaces found on mobile and computing devices. Candidates should be able to distinguish between the major connector types: USB Type A, USB Type B, USB Mini, USB Micro, and USB Type-C. Each has distinct shapes and is used for specific functions and device categories. For example, Micro USB was long the standard for Android phones, while USB-C has now replaced it in most modern smartphones, tablets, and laptops. Understanding which connector type fits which device is essential for both configuration and replacement tasks. In addition to physical shape, USB ports also vary by speed and version. USB 2.0, USB 3.0, USB 3.1, and USB 3.2 are among the most common versions tested on the exam. USB 2.0 offers speeds up to 480 megabits per second, while USB 3.0 and above can exceed 5 gigabits per second. Color-coded ports often indicate speed capability. Blue usually denotes USB 3.0, while black typically represents USB 2.0. Compatibility questions may ask whether a device or cable will work across different USB versions, making version awareness essential for mobile troubleshooting. Lightning is a proprietary connector used exclusively by Apple devices, primarily iPhones and certain models of iPads. It features a slim, reversible design that supports both charging and data transfer. Unlike USB-C, Lightning does not follow an open standard and is only available through Apple or licensed accessory makers. The A+ exam may present scenarios that ask candidates to compare Lightning to USB-C or recognize devices that use one versus the other. Familiarity with Apple hardware helps technicians identify compatibility and replacement options more accurately. Thunderbolt is another high-speed standard often found in high-end laptops, especially those used for professional or creative work. Though Thunderbolt can use the USB-C connector shape, its capabilities are distinct. Thunderbolt ports can support data, power, and video output through a single cable, often with much higher bandwidth than traditional USB. Because of the overlap in port appearance, technicians must verify whether a USB-C port supports standard USB only or includes Thunderbolt functionality. This distinction is critical when connecting high-performance peripherals or external displays. Bluetooth is a short-range wireless communication standard, commonly used for connecting peripherals such as headsets, keyboards, and file-sharing devices. It requires hardware radio modules in both the host and peripheral devices, and uses a pairing process that involves mutual discovery and authentication. The A+ exam may include questions on how to set up Bluetooth devices, secure their connections, or resolve problems such as connection failures or performance limitations. Knowing how Bluetooth fits into a mobile device ecosystem is fundamental. Establishing a Bluetooth connection typically involves placing the device into discoverable mode, confirming a pairing code, and accepting the connection request. Once paired, the devices may automatically reconnect when within range. Security is an important aspect of Bluetooth pairing, as unauthorized access can compromise sensitive data. Device functionality also depends on profile compatibility, such as A2DP for audio or HID for input devices. Technicians must ensure that the correct profile is supported when configuring Bluetooth accessories. USB-C has quickly become the universal standard for mobile charging and connectivity. Its reversible design makes it easier to use, and its ability to transmit data, power, video, and even audio through a single port makes it extremely versatile. USB-C ports can be found on smartphones, tablets, and laptops. Depending on the device, the port may also support advanced features such as DisplayPort for external monitors or Thunderbolt for high-speed data. Identifying the full capabilities of a USB-C port is essential for troubleshooting and accessory selection. Auxiliary audio jacks, including the 3.5mm and less commonly the 2.5mm connectors, continue to play a role in mobile audio. These connectors are used for headphones, microphones, or combination headset devices. The TRRS standard, which adds an extra ring to support microphone input or remote control functions, is commonly found in mobile headsets. While many devices have moved to wireless audio, these analog connectors are still widely used, especially in legacy equipment or environments where latency-free audio is required. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. High-definition output options such as HDMI and DisplayPort are commonly used on mobile devices for external display connectivity. Although standard HDMI ports are less common on thin devices, mini HDMI and DisplayPort outputs, often integrated into USB-C ports, allow smartphones and laptops to connect to projectors, monitors, and TVs. These ports may require adapters, especially when devices use multifunction USB-C connections to serve as both power input and video output. The A+ exam may include questions about identifying which ports can support external display configurations and how to choose the correct adapter type. Power-only ports are another category technicians must understand. Not every USB or USB-C port is designed to handle data transfer. Some ports serve only for charging and follow specific power delivery protocols such as USB power delivery or Qualcomm Quick Charge. Recognizing when a port supports only power and not data is essential when troubleshooting sync issues or attempting to access device storage. The exam may present a scenario where distinguishing between a charging-only port and a full-feature port is the key to resolving the issue. As mobile devices evolve, wireless alternatives have emerged to supplement or replace physical ports. Technologies like AirDrop, Wi-Fi Direct, and cloud-based sync enable data transfer and sharing without cables. These solutions are particularly useful when physical access to a port is limited or when devices lack compatible connectors. However, understanding the range and bandwidth limitations of each wireless method is critical. Exam questions may compare wireless and wired connections in terms of speed, reliability, and setup complexity. USB-C and micro-USB are two connector types commonly compared in mobile environments. Micro-USB was once the dominant charging and data connector, especially in budget Android phones and accessories. USB-C, by contrast, supports higher data rates, faster charging, and has a symmetrical design for easier insertion. USB-C is also more durable over time and allows for a broader range of functions, including video output. Candidates should be able to distinguish these connectors visually and understand their functional differences. Some mobile devices and accessories still use proprietary or magnetic charging ports. These include solutions developed by specific manufacturers that are not compatible with standardized connectors. Magnetic connectors offer advantages such as auto-alignment, reduced wear on physical ports, and increased resistance to dust or debris. However, they also limit interoperability and require brand-specific cables. Technicians must recognize when a proprietary port is being used and whether it affects the replacement or compatibility of accessories. Physical port damage is a common source of connectivity issues in mobile devices. Bent pins, cracked housing, or oxidized contacts can impair charging or data transfer. This type of damage can occur through repeated use, forceful insertion, or exposure to moisture. In many cases, damage is not immediately visible, requiring inspection under magnification or comparison to a known good port. When a port is damaged, replacement is often necessary, though cleaning with isopropyl alcohol may resolve minor corrosion. Troubleshooting mobile port issues involves a step-by-step process. Technicians should begin by inspecting both the port and the cable for visible damage. If the physical layer appears functional, testing with a known good cable or peripheral can help isolate the fault. Checking device logs and operating system recognition helps determine whether the system detects the connection. Driver updates and firmware settings may also play a role in resolving unexplained failures or charging inconsistencies. Dongles, adapters, and hubs extend the capabilities of a single port, especially on devices with limited physical connections. USB-C hubs, for instance, can provide HDMI output, Ethernet ports, and additional USB-A connections through a single input. These expansion devices may be passive or powered, with the latter being necessary for high-demand peripherals. The A+ exam may test understanding of when an adapter is needed and which type of dongle is appropriate for a given scenario. Near-Field Communication, or NFC, is a short-range wireless standard that differs from Bluetooth in range, speed, and energy usage. NFC is typically used for quick, secure interactions, such as tap-to-pay or device pairing. It functions at a distance of only a few centimeters, which enhances security but limits data capacity. Mobile devices may use NFC to trigger specific functions or share configuration data. On the exam, candidates should be prepared to compare NFC to other wireless standards based on use case and physical proximity. In summary, mobile ports and connectors form a complex ecosystem of physical and wireless interfaces. From USB variants and Bluetooth to HDMI, NFC, and proprietary charging methods, each connection type plays a distinct role in mobile device operation and troubleshooting. The A+ certification exam assesses knowledge of connector types, standards, performance characteristics, and problem resolution techniques. Mastery of these topics ensures technicians can support modern mobile hardware effectively and confidently. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.